He was telling he was telling me that, that's from the Bruneau Woodpile, and it's made of calcite, a kind of unusual mineralization. And so I bought a couple of pieces, and then as I learned more, I found out that the Bruneau Woodpile offers an incredible variety of different fossil wood types, which really fascinated me. So I wanted to visit. It's about 20 kilometers south of the town of Bruneau, and in the map here, you can see that it lies in kind of southwestern Idaho in the Snake River Plain. So the specimen that I've got there on the front there, you can see that there's little insect galleries as well. That's kind of neat, and you can see that it has cell structure. So as I started to investigate the Bruneau Woodpile, I talked to people who had been there a lot and learned how to get the wood from the deposit, because that's something that anyone who's gone out in the field and to different fossil wood deposits learns really quickly that you have to become familiar with the deposit to be successful. And so luckily, I had friends that had spent a lot of time there, and I was able to learn what kind of tools to take and where to look. Um, a lot of the wood is just on the ground in the soil, but if you want to really get good stuff, you've got to do some digging. Um, the site's been really popular among amateurs for many years, but also it's received scientific attention. So Roland Brown in the 1940s described a bracket fungus that came from the Bruneau Woodpile that had been collected by an engineer. And the engineer, James L. Morris, I mean, he didn't have any expertise in fossil wood, really. He was just an amateur, and he was out, during the afternoons and weekends looking for fossil wood. But he did have this connection with Roland Brown and gave him an example of a beautiful bracket fungi. And Roland Brown examined it and was pretty amazed at all the detail. And so he determined that it was a bracket fungi that had been described by Knowlton in like 1902 or somewhere around that time. And Brown also noted that there was a lot of fossil wood found at this deposit, and he identified the wood as fir, oak, alder, poplar, hickory, like woods. But he didn't give any reference to those identifications, and I don't think he had ever visited the site. He thought, based upon this combination of fossil woods, that this is probably Pliocene aged. And he noted that the fossil wood was found in a kind of a volcanic glass sand, and that it was well preserved with calcite. That was his determination. And he wondered, like, why is this calcite and not silica, especially since it was such a silica-rich environment that this wood was in. There was another paper in 1947, 7 years later, that also looked at the same type of bracket fungus. And so that scientific attention is kind of interesting. The site was interesting to scientists as well as amateurs. The kind of a big group of amateurs that was interesting was a group that was organized by the Gem Club of Boise, Idaho, and by two people, and they were really interested in identifying this wood because, as many of you know, if you go out and look for fossil wood, if you find more than one wood type, you're pretty happy. But at the Bruneau Woodpile, if you spend even one day there, you are going to get a variety of different kinds of hardwoods and conifers. I mean, it's like pretty amazing, and it's exciting because even just with a loop, you can tell that you got a diffuse forest wood that's kind of maple-like, or you've got a wood that's kind of oak-like or hickory-like, or like a Doug fir or a pine. And so, that's pretty exciting when you're finding all these different wood types. The picture's kind of difficult to see that was in the Gem and Minerals magazine, but that's a group of people that belonged to the Gem Club of Boise, and they were publishing their findings in this article. It's an interesting article to read, and you can see that they are actually, I can tell that they are digging and that they've stood up to take a picture. and they're digging different pieces of fossil wood out. And what they did is they thought, we can't even make thin sections of this stuff because it's just too soft, because they thought it was mineralized with calcite and gypsum. But what they did is they made 1 inch cubes from the material, and they would try to identify the wood from just transverse sections. But they were well aware that this can't be done for all woods. You need a radial and a tangent section as well for many fossil woods to be able to identify them. And so they were pleading in this article for help from the scientific community, because they said, this is a really unusual place. You're finding all these different kinds of woods, and we want to know what they are. So I've got, some of the woods there listed that they had found, or that they thought they had identified from the transverse sections, although they admitted that, their work was that they were amateurs. They needed help from the scientific community, and that they knew that they needed more views than just their transverse section. I have never found any of the little cubes of wood that they had made, but I'm guessing that they were pretty impressive because many of these amateurs had really great lapidary skills. And that would be something that would be fun to find, is like, what happened to their a collection that they had made? That is something that I don't know. So this was in 1971 where they were making this plea. Another important scientific find in this site was described by Axelrod in 1986. And basically, I have the I have the information wrong, I think, about the bracket fungus. It was the fossil cone that was described by Knowlton in like 1901. But Axelrod studied the cones that people were finding that were related to pinyon pine, and he identified them as something Knowlton had identified back in 1901, Pinus lindgrenii. And he thought these cones were silicified. And he thought that they were from the Chalk Hills Formation, late Miocene. And he also noted the work that Brown had done on the bracket fungus. And he also said, you find fossil woods here that are a great variety, like fir, oak, alder, poplar, hickory. And again, he doesn't give any reference to who's identifying this fossil wood, which I think is kind of interesting. And I don't know if he examined the fossil woods, but he acknowledged the scientific value of the cones that he was studying, which were collected from an amateur, Ruth A. Kirkby, who would later write an article about the Bruneau Woodpile. So in both instances, the bracket fungus and the cone, you've got a collaboration between amateurs and professional scientists. And this is, again, what the group from the club was asking for as well. They wanted that collaboration, but they never did get it. So here's an interesting article that Ruth Kirkby wrote about visiting, about 2 trips that she had made to the Bruneau Woodpile. On the left-hand side there, you can see that that's one of the cones that she found. And then there's another cone kind of in the center. At the upper right is a fish jaw from a type of minnow, a mollusc-eating minnow. And there's different kinds there. And I'm not an expert on fish, but I did have people who are experts look at the material we found. And, there are some that are restricted to the Pliocene, some restricted to the Miocene. So Kirkby describes how she went and found different fossils on the ground and in the soil. She also describes digging some out of a hard material, which obviously was material that was in place within the fossil bed. And in the bottom picture, you can see some of the things that people liked about this site, because there's pieces that look like driftwood, and then there's just chunks that look like they've been rolled and eroded. And then the little piece that's kind of like cigar shaped on the lower left is one that's been polished on the outside. And the Bruneau fossil wood is brown in color and has great character. And a lot of people will polish the material. And when I polished the material, I started thinking, this is harder than calcite. is this really calcium carbonate? And so that was one of the things I was interested in trying to find out. And I also talked to people in Idaho, and they thought, well, we think maybe it's Pliocene, that it's associated with ancient Lake Idaho. And I wondered about these things. So Kirkby did note that you see a lot of insect damage. She thought it was the White Cliffs Formation of the Pliocene age, which is actually not a thing. I don't know where she came up with that idea. And she and the club members thought that this fossil wood was associated with ancient Lake Idaho, the Pliocene. They referred to the cones in this article as silicified. And one thing that I love about her article is that as even though she's an amateur, she's sitting there in a place that's just populated by sagebrush and bunch grass and dry. I mean, today Idaho gets like, less than 200 millimeters of precipitation a year. And she just marveled at the idea that these fossils spoke to a past environment that spoke of lakes and fish and forests. And I just think her appreciation of what the fossils were telling her about the past environment is a wonderful thing to read in this article that appeared in Gems and Minerals. So I started out by just trying to get to know the site. So this is Mary on the right side there, my wife, and then on the left side is Bill and Carol, really good digging friends. And Mary and I went up there alone the first year and just thought we need to know how to work this site. And we had gotten some really important information from some friends who were experts in the area. And so we just got to know the site, figured out how to find wood. And if you go and you're going to be digging, you really have to have the right tools because the material that you're digging through is like concrete and it's not easy to remove. And so we got to know the site, and then I thought, well, we need some other experts. And luckily, I'd already been working with George Musto of Western Washington University and Paul Link, a geologist, on some other projects. And I said, let's take a look at this material. And they said, sure. And so we started a collaboration, and then Tad Dilhoff joined us for wood identification, and Rick, his brother, joined us as well. And so we just started, trying to figure out. Let's learn about this site. Let's see if we can figure out what age the site is. Let's figure out what kind of woods are there. And so we were on our little adventure, and it was wonderful. In the end, we spent 3 seasons there collecting material, and we found a couple of different sites. I think one site may not be known really to collectors. That was a really great site. And I think they all represent kind of like the edge of a lake that was there in the late Miocene. And we just call it the Chalk Hills Lake. The lakes in this area started to develop and coalesced into one giant lake during the Pliocene. But this, we found out, is an earlier time at our site. You really have to be prepared in this area because at the time that we were digging, you have to stay well hydrated and you have to have shade because it's pretty intense, the environment, and it's hard on you. So this is a picture of preparing for the day at the site where we actually collected material that became a part of the study. And so Mary and Bill and Carol are setting up their tools, and they're going to set up shade and start the process of digging. And if you want to extract material that has been that's in place in the fossil bed, you really have to spend literally hours preparing an area very carefully that you can photograph and take some measurements, and then once all that's done, extract the wood. And it can take more than half a day just to prepare a little area to extract wood for study. So this is a picture of at the end of the day, and on the far left is Tad Dilhoff, and then his brother's in the white shirt, Rick. And then Paul Link is in the foreground there, and he's now sitting down, but he carefully went through and collected material to describe the stratigraphy of the site. Now, I've got just kind of a stratigraphy here that gives you a sense of what it's like to dig. So, as you dig down to the fossil layer, the first thing you run into is just the soil. And then you start running into this wonderful gray ash that's really, a silica vitreous gray ash that's pretty thick. And then you start running into siltstone and clay. Then you run into another ash layer, run into more siltstone and clay, and then finally the fossil bed. And some of the clay and siltstone is like trying to remove concrete. So the digging, you have to be in pretty good shape to do this digging. Although there's a lot of people that go out to the site and they just find stuff, on the ground. And like Ruth Kirkby found fossil cones and her fossil wood just on the ground. The only thing that she dug out was a little bracket fungi that she had found. So a lot of people just enjoy walking around and finding things on the ground and in the soil. But for the scientific study, we wanted to extract material from the fossil bed. This is the generalized stratigraphy that Paul came up with. And as you can see, it's a lot more complex than what you think when you just look at the layers visually. And so there's, a fossil bed kind of at the bottom, and then material that represents two finding upward cycles in a lake environment. And then you've got two very clear ash beds. And I've got some pictures on the right. Oh my, I don't have my magnification on there. But so the picture on the bottom is the ash layer that's just above, a little bit above the Bruneau Woodpile fossil bed. And what you're seeing there, the little white structures are actually pumice, and then the darker structures are kind of more vitric glass-like material. And I know that Paul Link is with us today, so if I'm getting something wrong, he can correct me in the Q&A. And then the upper picture is the ash bed that we were actually able to date. And I think that in the end, to date that, we used a chemical method of dating. So it was a chemostratigraphic kind of dating. And the person, I believe the professor's in Arizona, and she's been dating and correlating ash layers in Idaho chemically. And it's really great work. And it was very affordable for us because we didn't have any funding for our project, even though, and that was the other great thing is, I guess I'm a science educator, and I was overwhelmed by the fact that these scientists would join me in this endeavor to study this site. And they didn't ask for money. They, just wanted to enjoy learning about the site and sharing their knowledge and supporting me and supporting the team. And it was really an amazing experience. The ash layer above is more glassy. I mean, I can't even imagine, being there when these eruptions, excuse me, took place, because what that would do to your lungs would not be good. But the date on that ash layer was 6.84 million years. And so that placed the Bruneau Woodpile down below in the late Miocene. So we had finally figured out the age of the fossil deposit. Although, to be fair, the people who had previously said that it was Pliocene is, the date for the Pliocene, the beginning of the Pliocene was changed back in 1969. It had been 14 million years, and they had changed it to 5.3 million years. So knowing that, some of the people who thought it was Pliocene, today with the current information and definitions, maybe their estimate would have been late Miocene as well. Here's a close-up of fossil wood. Once you get down to, and you've removed all that material up above, this is what you see. And so these are limbs, and you can see they're quite long. And some of them are already kind of broken into sections. There's a lot of full rounds, but even the full rounds, for the most part, have tapered edges. They don't have their bark. They're stripped usually of branches. And then there's also large pieces that you find that are also driftwood-like. So all of this material looks like it's been transported and eroded a little bit with the bark off, rounded. But still, the wonderful thing about this site that I'm sure the amateurs really appreciated is anyone who collects fossil wood loves to have full rounds, and you find them in abundance here. All the little white pieces that you're seeing, and some of them even look like stones, are actually pumice. And then there's obsidian granules that are sand size, and there's sand. And, so there's a lot of volcanic material here. And it looks like when the first time you're there, it's so funny because you uncover this stuff and you get so excited and you see a limb that you're just like, oh yeah, I want to add that to my collection. And this is on BLM land, so you're allowed to collect a certain amount. But what's funny is you go to grab it and it doesn't budge. And it's just like, it looks like you could just pull those out, but they're like cemented together with this volcaniclastic sand, and they're not easy to remove sometimes. And you have to be really careful. And on one limb, you can sit there and dig around it for what seems like forever to actually finally extract it. But you can kind of get a size comparison with the rock hammer that's there. So here's another picture of material that's been uncovered. And here we can see pieces that are more driftwood-like. One of the things that I think is kind of interesting is you do find snails and fish bones all cemented together with obsidian granules and pumice and the fossil wood. I kind of think I see some interesting patterns too with the fossil wood that would need to be studied more analytically to be confirmed, but I can explain my thinking later here in the presentation. So here's a slide on the right that shows you some of the morphotypes of the fossil wood. Basically, you just find two morphotypes. I mean, one is driftwood-like, where it's just a part of a tree, branch, or trunk, and then you find the full rounds. And those are the basic types that you find. The bottom left-hand corner is a beautiful fossil cone that my friend Carol and Bill Evans found. And it's so funny because, we were there for 3 seasons, maybe 4, I can't quite remember. I know our study took 3 years, but the first, couple of years that I was there, I really wanted to find a cone. And we go up there and Bill and Carol had joined us. And so I start digging and I show them what to do. And then Carol says, well, can I dig beside you? And I say, sure, And all of a sudden I hear, she goes, Mike, I think I found a cone. Do you want to come look? And sure enough, she had found a cone. So we took a picture of it before we extracted it there. And you can see Bill's pocket knife by it. And then there's also fossil wood there and pumice. But it's just funny how long I've been up there, and I've actually never found a cone or a bracket fungus, but I found a lot of great wood. Here are some pictures of the thin sections that George and Tad made. So Tad visited George Musto at Western Washington University, and they started to make thin sections of the very best specimens that we had found out of like 200 specimens. And we can see that we've got an oak-like wood there, and you can see seasonality to it, and also a pine with the resin canals. But what was interesting is when you look at this wood with your loop, you're like going, oh my gosh, that's beautiful cell structure. But then you make a thin section of it, and the structure's not quite as good as you thought on a lot of specimens. And then when you make the radial and the tangent sections, there seems to be even less structure. I would still say that even though this material is not silicified, the way it became preserved still follows kind of that templating process that we think occurs with silicification. I made a little drawing there of showing you transverse, radial, and tangent, and we ended up only being able to identify fossil woods mostly from transverse, although I believe that Tad, who is not able to join us today, said there were a few radial and tangent sections that were actually helpful to him, but for the most part, radial and tangent were not. They also had, if I believe at this point, I had never made thin sections until after this study, but I believe we can ask George Musto. I think they had to make the sections a little thicker than normal, and they were having some problems with bubbles in some of them, and it was not easy material to work with if memory serves me right. So we did confirm some wood types, and we actually I know that Tad ran these identifications by Elizabeth as well, and she actually identified one that we had not identified that was interesting. But there was material from the cypress family, pine, spruce, Doug fir type, Oregon grape, black locust, white oak, live oak, hickory, willow, maple, elm, four unidentified hardwoods, and I think a lot of material that might represent bushes and vines. But I think there's still a lot of that could be studied about this site that would be fruitful. Especially, there's a lot of I guess nuts that are found at the site which we didn't run into, and I haven't seen anyone write papers about. But I think there's someone in the audience that might be able to tell us more about that. So um, I did kind of my own work just from transverse sections. Here's some more of the thin sections that Tad had made. And I thought, well, I noticed that um, the conifers are kind of more unusual, especially ones with resin canals. So I just thought, like, what do I find from like, looking at a couple of hundred specimens? And I found that angiosperm dicots that are diffuse porous are the most common thing you find. And then angiosperm dicots that are ring porous, like that elm, and then gymnosperms are pretty much equal. But then the gymnosperms with resin canals are the most unusual find. And so I made a little graph to show you that. The other thing that I noticed, or what I think I see, is that for the full rounds, they are usually angiosperm dicots. And most of the gymnosperms are usually chunks of wood. And in fact, I noticed that oak, it's rare to find oak, which is an angiosperm dicot too, as a full round. They're usually, driftwood-like, and so are many of the conifers. So I feel like there are some oak type woods and conifer type woods that must have been transported from further distance into the lake just because of the nature of the morphotype that is represented by the majority of that material. But that is speculation on my part, and I haven't actually studied that number wise. Here's another image of some fossil woods on the top left. We've got a hickory-like wood, transverse thin section, and then a live oak on the right. Bottom, boy, I must really like that picture. We've seen that picture before. And then on the right side is a fossil limb that has a fish jaw cemented to it and a fish vertebra. And you can see the obsidian and the pumice. And that picture is just to show you, the nature of the material that's all cemented together. So here are some graphs that were made by George Musto, and we studied the wood using X-ray diffraction and energy dispersive spectroscopy using SEM. And both methods indicate that this is a carbonate-rich apatite. Maybe similar to what people call a francolite as a mineral. And so that was another kind of big breakthrough. So we found out, well, it's late Miocene, and it's not composed of silica, which we knew. It's not composed of calcite or gypsum, which some people had speculated about. And this made more sense to me. When polishing it, I thought, yeah, this is a little bit harder material than calcite or gypsum. Here are some nice scanning electron micrographs that George Musto took from Western Washington University that show the microcrystalline structure of the carbonate fluoroapatite that has preserved the fossil wood. And you can see in the top left corner a conifer, and not sure about the others, but we're seeing vessels um, and tracheids preserved in apatite. So here's the conclusions from our study. We believe from the data that we collected and analyzed that the Bruneau Woodpile fossil deposit is late Miocene in age based upon the ash bed that was chemostratigraphically dated. And then we also found three fossils that are restricted to the Chalk Hills Formation, a minnow, a mollusk-eating minnow, and a fish and a snail. So you have both biological and chemical data that help place this in late Miocene. The fossil wood and the cones are mineralized with the carbonate-rich apatite. In looking at the way, the wood is laid out in the fossil bed, we speculated that, there might be different ways that it ended up there. But in the end, if you read our paper on this, you see that we favor a high energy rain event that most likely carried wood that had already become saturated and the pumice and the sand into the ancient Chalk Hills Lake. And once buried there, the chemical conditions favored the precipitation of apatite. The source of the apatite, or the source of the phosphate for the apatite's not known. There were some large deposits of that material near this site, but the extent of the formations are not known. So, it could have been the source of the phosphate could have been biological from fish decay, or it could have been from a phosphate deposit nearby. We just don't know. But I think one thing that's interesting is you've got the fish bones that are intact, you've got fish jaws that are intact, and they're with wood that has been mineralized with apatite. So I think maybe the chemical conditions for the wood itself as it decayed favored the precipitation of apatite, from the waters that were there. The fossil flora kind of indicates some seasonality with summer dry tolerant species. And one thing that's interesting to me is that you can tell that this forest grew before the uplift of the Cascades had produced a significant rain shadow that today makes this area very dry. And so this is before the expansion of the grasslands in the Pliocene, and then finally the evolution of the sagebrush, bunchgrass, steppe flora that dominates the area today. And there have been some pretty cool. There's one really cool paper by Leopold, I think, and Musto that looks at different fossil deposits on either side of the Cascade Range over time, and shows that the fossil deposits themselves help to date the uplift of the Cascade Range, and based upon the development of this rain shadow that's produced by the mountain range. So I think that's kind of interesting. So, I guess maybe the forest that existed back then in the late Miocene might be something like the mixed pine and oak forest in Georgia. That might be a modern analog, although I would defer to Elizabeth Wheeler on that. So I just want to thank you again for joining our presentation today and letting me share my passion. Again, I'm a science educator, and I guess I'm an amateur and fossil wood enthusiast. And I think, although I'm not a professional paleobotanist, I really appreciate collaborating with professional scientists and learning from them, and also supporting them in learning more about some of the fossil deposits that I've been passionate about and that I have some knowledge of. So thank you again for joining us. I guess we're going to have a Q&A session, and that kind of wraps it up for my presentation. And I hope you enjoyed it.
Thank you, Mike, for your wonderful presentation. We appreciate that, and thank you everyone for still staying with us. For Q&A section, I will transfer to Inda to be our moderators. So welcome, Inda.
Yeah, well, thanks everyone so much for coming to attend this seminar. We do have quite a bit of time here for questions, so please feel free to post your questions in the chat or raise your hand if you want to ask out loud.
I have a question, Mike.
Yeah.
You mentioned insect galleries at the beginning.
Oh, yeah. So, that was another thing
Can
that
I
was going to.
I have a question about it. Do you ever use insect galleries as a dating method after you look at it on the microscope,
Yeah, I'm not sure. I would defer to Inda Higley on that question, but I would say that there was one thing I wanted to say about the insect galleries, and this is another pattern that I think that I recognized. But I mean, I have looked at hundreds and hundreds of Bruneau fossil wood specimens, and I tend to think that the ones that most commonly show the insect damage are the elms. And I think that's an interesting pattern if that's true. But that's my perception after just looking at hundreds and hundreds of specimens, because I'm always looking for insect galleries. And I do want to say that Nancy Dillon is with us today. And Nancy and Doc Dillon are fossil wood enthusiasts that are experts on many, many fossil wood deposits. And if it weren't for their kind and generous sharing of not their knowledge about the fossil wood deposit, this study would have never been made. And also, I want to thank my friend Jim Mills as well, because we go way back, and he's always encouraged me and also been a part of researching fossil wood deposits. And sometimes, as an amateur, you feel a little bit intimidated because you're not a professional scientist. But I think, working together is fruitful. And so I just wanted to recognize those people. And also Paul Link is with us today, who is the professional geologist who helped us at that site and helped us with the Clover Creek site as well, another fossil wood site. And so, yeah, Don, I don't know your question. Maybe Inda might say something. I don't think it is, but Inda might know something different than me.
Yeah, I don't know if I have much to add on that since I'm not as familiar with specific types of insect borings and that field of things, especially when it comes to wood. All right, so we have a couple of questions in the chat here. First one is by Mary, asking what is the age of the deposit compared to the fossil wood in the fossil forest kit?
Oh, yeah. So that was another thing. I'm glad that Mary asked that. One of the things I wanted to say is that one of the things I've strived to do for all the fossil wood deposits that I've been studying is I like to hook up with scientists, professional scientists, to produce a scientific paper on the fossil wood deposit. Then my second goal is to produce a paper that's for a general audience. And my third goal is to produce curriculum for schools that is based on the fossil wood deposit. And I think that I would also encourage other professional scientists to hook up with science educators and think about promoting that which you're so passionate about. Because I think the best definition of leadership to me is taking responsibility for something that matters to you. And if the things that you study matter to you, then I think that it's important to get the next generation excited about it as well. So for the Bruneau Woodpile, we did a scientific paper, and then we did a general paper for rocks and minerals. And then I developed a curriculum for school children to learn about stratigraphy and what can be learned about past environments by studying fossils that was tested in Estes Park, Colorado. And actually, the teacher that worked with that is now working on her doctorate at Colorado State University, and she's going to use that curriculum as one of the things that she's doing during her doctorate experience there. And we're going to try to develop it more into even a better activity. Mary mentions another fossil wood deposit that I've studied and that we continue to study called the Blue Forest in southwestern Wyoming, and that's Eocene aged. And so with that fossil wood deposit, we've done some scientific work on that, on the mineralization of the fossil wood. We've done general papers, and we developed a STEM kit that's a hands-on kit that's part of the lending library at Colorado State University, where the kit can be checked out by local teachers, and students learn to look at real thin sections and learn to interpret major wood types. And interpret past environments through this kit. And so I guess that's one of my goals as a science educator, is to try to tie scientific work to and share that with general audiences, and then to also share that with teachers, because a lot of the science curriculum that you run into is often, generalized to such an extent that I think you lose some of the interest. It's so wonderful, instead of just learning to do stratigraphy with, made up diagrams, to actually use a real generalized stratigraphy of a real site. And I think that is inspiring to students. So I think that's another thing that that I strive to do. So yeah, Mary, it's a big age difference there. And one wood silicified, which is kind of more common, and then the more unusual Bruneau site is mineralized with the francolite.
We have another question here from Johan Morris asking, what other, or have you looked at other wood piles? And if so, what locations?
Okay, so for this site, they call it the Bruneau Woodpile. I think maybe Jim and Nancy might have a different view on this, but I feel like they called it that because it reminded them of wood that you find around a lake, or that's been transported by a stream, that's all piled up together, and you can tell it's been rolled and weathered. And also, there were just so many different kinds of wood types they were finding. So I've studied other fossil deposits, but I wouldn't call them wood piles. I would just call them fossil wood deposits. So I've studied sites in southwestern Wyoming, other sites in Idaho, sites in Utah, and in Colorado as well. And so, yeah, I've studied multiple deposits and would like to study more.
All right, great. So we have quite a few here in the chat. This one's from Hazel Gordon asking, has anyone looked for traces of paleosols in this area in a more terrestrial environment?
Oh, yeah, that's an excellent question. And not to my knowledge. There might be someone in the audience that would know more about that, but I don't know of any paleosoils associated with this from the fossil wood that's associated with this deposit. But I like that question, and I've never actually even considered that. So that's a very interesting question, Paul.
So, Mike, there's an unconformity. This is Paul.
Yes.
There's nonconformity on top of the Chalk Hills below the Glens Ferry. And at that unconformity, uh, that's where the oolite beds are found. Uh, and you would think there would be paleosols maybe up in the Boise foothills. I don't know the specifics, but I don't know of any other paleosols in the stratigraphy.
So,
Yeah.
so this is Nate. This is Nate Carpenter. Hi, Mike. How are you?
Oh, doing well, Nate. And Nate, I really have to thank you too for your help with the fish identifications. And also, Nate pointed something out to me that I think is really interesting. Is he showed me or he shared with me a 1902 paper that seems to mention this site in a few sentences. And they describe the wood as silicified and as rolled and weathered. And I have to thank Nate for that. Nate has been incredibly helpful and actually has much more knowledge than I do about different sites in this same area that are very productive. So thank you, Nate. What's
You're
your
welcome.
question?
Well, I was going to add to Paul's deal. So you're on where you're digging at primarily, where your pictures were at,
Mm-hmm.
are on the north, kind of the north in Little Valley, but on the north edge of what's called Sugar Creek. And on
Mm-hmm.
the south side is another Bruneau Woodpile.
Yes.
I don't know if Howard Emery took you there or not, right?
Yeah. Yeah.
That's all, okay. And in between are paleosols down in that Sugar Creek that lead up to when the lake level starts. And
Oh.
so Paul, that's the Sugar Creek stuff that Roger Rapp did his thesis paper on. The collection is in the museum there at Idaho State University, and it is clearly Hemphillian. And the oldest, so Barbara has looked at that section for us over there at Horse Hill, and the oldest date is an unnamed ash at 8.1, and you go up to about 7.4, which is the Foss Tuff, and then that's all paleosol, that's all terrestrial, it's all floodplain deposits. Mammal bones are the predominant, and good fragmentary, right? Never complete skeletons. And then you transition into the lake zone that leads you up to the Hot Creek algal limestone. And above that, we have another fish and wood layer, and it sits below where Paul is talking about on Horse Hill, below the Glens Ferry unconformity, and the Walcott Tuff is there. So you get what's happened is the regression of the Chalk Hills Lake washed away most of the upper portion, and so you're only seeing like 6.4 to 8.1 million here locally. And then right above that is the basal portion of the Glens Ferry. There is no oolite there locally. It is a red ferruginous sand with a rhyolitic cobble from Nevada, that layer that's on top of it. That's the transition. So there's a large, that sand was dated at 3.3. It's the Ishi tuff, I think, and the Nom Lakey tuff are in that ash. So you jump from 6.4 million to 3.3, and at the base of that, in that sand, is the other wood pile that I wanted to talk to you about, which is clearly Glens Ferry.
Oh, okay. So Nate, now you're turning me into the audience and wanting to ask you a question. So can you tell us what kinds of nuts and or fruits have have been found from this area?
So I hear a lot of people say that they found hickory nuts there, right? I've never seen a hickory nut locally, but Paul had joined us with another guy to go to what's called the Wayne Lewis Nut Bed, which is in Browns Creek. Paul, do you remember going there with your two students a couple years ago? That's where we got the older,
Oh,
the
right,
seven.
right. Yep.
Yeah, so we did some crystal analysis on that. That has also been dated. That's the oldest part of the Chalk Hills Formation. It has the Rush Valley Tuff at the base at 8.35 million. That contains at least two types of nuts. And there is literally a nut bed there. There was a tree there that shed a lot of nuts. They're in really good condition. They have insect galling on them. They still have the fruit inside, and it's agatized. I'll show you when you come out some beautiful collection of that kind of stuff.
Okay.
It's
I'll be leaving here in 10 minutes.
okay. I also have from the lower part, it's pre-mineralized wood, so it's punky. It's not good. We're way down at the bottom. I'll take you there. It's punky. I
Okay.
found what looks like an almond. I mean, if you looked at it, you think it was an almond. That's exactly what it looks like. Almost perfectly preserved. And we get a lot of cones. And here's the interesting thing about the cones, Mike. They almost always have seeds in them. They're not
Yes.
cones that, when you throw an old cone in water, even if it shed its seeds, it will close back up again. But all the cones I have seeds in them.
That's a really good observation, Nate, because I've noticed that too.
And then just real quick, I want to dominate your story here, but you ask about the little wood blocks that they made, right?
Yes.
Jerry Smith had told me that the club and several of the club members from the Orma J. Smith Museum have told me that back in the 60s and 70s, they were making kits and selling them. So they were taking those little wood blocks, so once they identified one of the little twigs, they would make a whole bunch of blocks, glue them into a little frame, and they had labels. I have never found one. But
Wow.
I've heard many stories that such a thing exists. So I continue to ask club members. I mean, we've got club members that are almost 100 years old. So I'm hoping that one of them one day will show up with one of these kits.
That would be great.
Well, thank you so much, Nate, for contributing that. The fruits and the cones and all of that sound really exciting. Oh boy.
The bracket fungus that we have at the museum is fantastic. It is over the top. It is complete horseshoe conch. You can even see where it had wrapped around the limb when it was growing and everything. It's in perfect condition, Mike. When you see it, it'll blow your mind.
Oh, I can't wait to see that.
I mean, I consider it better than the one in the Missouri Botanical Garden. It's fantastic.
Wow.
All right. I'm gonna go back to some other questions in the chat here. Is there any report of fossil pollen from the woodpile?
Not that I know of. I think that Tad has done a lot of work and continues to finish up some work, even though he's retired, on pollen. And if memory serves me right, as he was thinking of that for our study. And because he's done quite a bit of work with pollen and is good with that. And if memory serves me right, he was like, we're not going to get pollen from this site. But the picket leaf flora is a site where you get leaves and pollen. And I think that time-wise, it's similar, maybe to ours. I don't know. Nate may disagree with that. But that was the thinking of Tad. But Tad did think of that. And he said that this site wasn't conducive to doing a pollen study.
All right. Yeah, Mike, the Pickett Creek flora is in the Poison Creek Formation, so it's bounded by ashes that date 8.5 to 10 million years.
Okay, so it's a little bit different.
And the cool part about it is the type specimens are in the University of Michigan. The co-types are in the collection here at the museum. You'll be able to. Beckler turned his collection over to me, so I have all the samples, the diatoms,
that's cool.
everything.
That's awesome.
Right. Pivoting back to the kits again that you're mentioning, Mike, Elizabeth Wheeler has a question asking, do you think that the kits dealing with Miocene material are more or less successful than the Eocene ones?
Oh, well, so we don't have a kit for the Miocene material. What we have is it's an activity that as a science educator, it's going to be developed into more of a jigsaw activity. But what we did with the kids up in Estes Park, and we did this 2 years in a row during the pandemic. And so I couldn't visit the school personally. So we had to do a Zoom meeting. But what I did was I sent samples of the fossil wood to them and some thin sections to look at underneath the microscope. And so we started to teach them some basics about wood anatomy and kind of what type of tree is this in general, like is it a conifer or is it an angiosperm dicot? And for the Bruneau Woodpile, there's, obviously no palms, but we did just those two categories. And then we taught them, we showed them the stratigraphy and got them to interpret the stratigraphy, a generalized stratigraphy themselves. And then we move them to interpreting what is it that they think that these fossils that are found in the layer are telling them about the past environment, and how would that differ to what the environment is today. So they went kind of through a process, and then the teacher used some kind of, so there was hands-on, there was interpretation of charts and graphs, and then there was also a reading assignment or a writing assignment that she did at the end that has a special name that's popular among educators now. And I don't know what that writing assignment was, but it also is a way to assess what the students learned from the experiences that you've just given them. And that's when she really became excited about developing this curriculum further, because she said, the results just show that they learned a lot from this and that they're excited about it. And so that whole curriculum is going to be turned into more of a jigsaw curriculum, and I don't know what that's going to look like. But the kits themselves are different. So the kits for like the Blue Forest, they get a box, and in the box are all these hands-on materials, and they get a little booklet, and the booklet guides them through 5 activities that tell a story. It's kind of like a story arc. And by the end of the story, they're able to identify 3 basic wood types with the thin sections and actual real wood blocks that are modern. And then they also learn to interpret a past environment based upon the fossils that are there. And we actually used your idea that you did at the fluorescent fossil beds, where you had the graphs showing the temperature ranges that the fossil plants probably grew at based upon modern data. And so we copied your idea in our kit using a similar graph that helps the students figure out what do they think the annual temperature range was for these combination of plants growing in Blue Forest. And then that also leads to climate change. Yeah, so that one is a hands-on kit that is designed for 2 students to work through together. And then as groups, they all come back together and see what they learned from their kit and look at bigger patterns. And then the other curriculum was not a hands-on kit, but it was, fossil wood to look at, diagrams to interpret, and then a writing assignment. But good question. I think both were equally successful, but in different ways. They both spurred a lot of interest. And because, to tell you the truth, the curriculum in the United States leads to plant unawareness, in my opinion, because at the very beginning of the curriculum in kindergarten, they learn some basics about trees and the parts of a tree. And then from there on, the curriculum turns to more abstract ideas about photosynthesis and cellular respiration, and a little bit about biomes and the roles that trees play. But really, in the end, if you take a kid to the window in a classroom and have them look out at trees and you say, do you see, any conifers, or do you see angiosperm dicots, or in what kinds do you see? Do you see a maple? Do you see a cottonwood? Do you see an oak? They can't do it. And so it's bewildering to me that we have a curriculum that doesn't teach students some basic things about trees when they're so important to our society and our planet, quite frankly. So I guess that's another thing that I'm trying to do and influence.
Mike, could you flip to the second slide real quick?
Sure. Just wait 1 second.
So we are reaching noon here, and we are
Yes.
limited on time. Maybe we could take 1 or 2 more questions here, but if there are any other questions that we can't get to at this time, please feel free to reach out to us and send your question to info@fossilforest.org. I'll put that here in the chat. But we have 1 more question about the paleo soils again. asking about, do you have any speculation on the origin of the 25 plus centimeter band of white clay in the upper soil profile?
Okay, so let's go right here. I would defer to our geologist, Paul Link, if
What's
he's
the
still with
question?
it.
What's the
Can you,
question, Clay?
Inda, can you repeat the question?
Yeah, sorry. The 25 plus centimeter band of white clay in the upper soil profile
Right,
is a question.
right. So the first thing is we wouldn't call this a soil profile. We would call it a stratigraphic section because it's really not soil. And the second thing is the massive white clay. I would think that's just lake silt or lake clay. So deep enough in the lake that the kind of debris flows and things which the Bruneau Woodpile represent and the graded beds, the sandy ash beds, wouldn't reach it. So deep lake. And the other thing I would mention is the phosphorylation of the wood has got to be from the lake waters. I think the speculation that it has anything to do with the Permian phosphoria formation, which is not found anywhere near here, is too complicated. It's got to be, and this lake. Remember, this lake is drastically influenced by volcanic eruptions, and so the chemistry is going to be unusual. Anyway, so yeah, deep lake.
We have one last question here from Johan Mars about how would I get a blue forest kit?
Oh, well, that's a really good question. So the way our center works at Colorado State University, we're the Education and Outreach Center, is that we work with scientists who have grants, and we usually do the educational outreach component for that grant. And the educational outreach component of the grant is fulfilled by developing a kit that tells students that range from grades 4 through 12 a story about what that researcher does. And so then once the kit is completed, it takes about a year to develop one of these kits and test it out and make sure it's working well with students. Then 15 identical kits are made and become a part of our lending library. And the topics just range, are as diverse as the professors at the university. And so then, we have these 15 kits and teachers check them out. We send them out, they use them, they come back to us, and it's all for free. And then we refurbish the kit to get it ready for the next teacher who checks it out. We're not in the business of selling these kits. It's just a way to make educational outreach from grants sustainable. So we've got kits that represent professors that have moved on, have retired, have gone to different universities, but their kit is still in our lending library and still being checked out. So it's a real sustainable way to take grant money and make an educational outreach component that is sustainable and that continues. So the other difficulty with this kit in particular is that the thin sections, we were really lucky because George Musto volunteered to make the thin sections for us for all 15 kits. And so, we'd have to find a way to make more thin sections. We also have, I don't know if Andrew Warnock is with us. He's my boss and the head of the Education Outreach Center. But we do make all of the materials or directions for making the materials of the kits available to anyone who wants them. So we 3D print a lot of materials. So we have a really cool microscope that's really high quality where the parts were designed by us and 3D printed, and it disassembles and assembles in a really convenient manner for the kit because the kits are small. But the microscope's awesome. It even has a little light box for it to view the slides. That's also 3D printed. So we're happy to share all those materials with someone. I think the best thing to do is if you really wanted a kit, you might be able to ask Dr. Andrew Warnock at the center if there's a way to do that. But just seeing how the kit works might give you ideas for making your own kit as well.
And I pasted a link to the CSU EOC lending library in the chat here, in case you guys want to contact Mike or Andrew's organization about that directly. But thank you guys so much for coming and seeing the presentation today. Again, if you have further questions, please feel free to reach out to us at info@fossilforest.org. Oh, sorry, Mike.
And I just wanted to recognize another person. My dad is with us, and he's waving. He's 92, going on 93, still writing papers, really amazing. And I have to thank him because he took me on my first fossil wood hunt when I was in 2nd or 3rd grade. And that's what kind of ignited it all. And then my philosophical views of fossil wood and past environments have been influenced by my brother, who's a retired philosopher. So, and then Mary, my wife, who helps me dig and just loves to dig. So, thank you all.
All right. Well, thank you so much, Mike. Thank you all in the audience for coming to see our very first seminar here. We'll make the recording available online, and yeah, hopefully we'll see more of you in some of the future seminars we have. Right.
Yeah, thank you.
Everyone.
Have a great day.
Thank you.